Continuing to look at inequalities or linear inequalities, we have a graphed linear inequality. We're going to be asked to write the inequality that goes with that graph. So let's look at, I'm going to do two examples with you. I'll try a couple on your own. If I'm going to write a linear inequality, it's going to be in that form y equals mx plus b, so with an inequality instead. I need somewhere to start. I'm just going to write this y mx plus b. I'm not going to put the equal sign because these are inequalities. So let's start with the y-intercept. That's pretty easy to find. There it is right there. So the y-intercept, 1. Got it. Positive 1. I'm on my way. I've got to start. Now I need the slope. So I'm going to pick 2 nice points. That's not a great point. It's hard to figure out exactly what that is. That's a tricky point. Ooh, this is a little bit better. That's a better point right there. So I rise and I run. It's going to be the rise and the run. So the rise, 1, 2, 3. The run, 1, 2, 3, 4. So I've got 3/4 x plus 1. That's the equation for that line. Now I need to know, is y greater than the line or is y less than the line? Since it's shaded above the line, y is going to be greater than the line. And since it is a dashed line, we put no equal sign underneath. We're not going to put that there. And so it's going to be y is greater than 3/4 x plus 1. Any y value above that line, y is greater than that line, will work. Let's do another one together. Okay, so again, I'm going to use my form y equals, or y mx plus b, because I don't have an equal sign anymore. The y-intercept. Y-intercept, it's not counting by 1s. I notice that the scale is different. It looks like it's counting by 4s. So it goes 0. Oh, it's counting by 2s. -2, -4, -6, -8, which means that's probably going to be -5. And on any test or quiz, I would give you, or even an assignment on Schoology, I'm not going to make it be like -5.1. I'm not that mean. So -5. Now I need another point to use that makes it easy to find the slope. I could certainly use this one here, or I could use that one there. Doesn't really matter. I'm going to use the x-intercept just because. So if I count up, I'm going again from -5. So the rise is -5. The run, it's going all the way over to -10. So it'd be -5 over 10. However, I do need to reduce. -5 over 10 is 1/2. And so it'd be -1/2 x minus 5. And I need to figure out, ooh, that wasn't good. Put those back. I need to figure out, is y greater than or is y less than that line? Well, all the y values down here are all below the line, which means that y is going to be less than that line. And since it is a solid graphed line, not a dashed line, y could be equal to that line. So y is less than or equal to that line. We've got our graph. We've got our equation, our inequality. Give these two a try. Figure it out on your own, pause it, see what you get. Okay, I'm going to write the inequalities on the board and see if you got the same. We get y is less than -x, and y is greater than or equal to -2x minus 3. If you didn't get those solutions, watch the linked video and see how to get those answers. Okay, moving on. We've done graphing, linear inequalities. We've done writing the inequality based on the graph. That was what we just did on the last video. Now let's do some more real-world situation. How am I going to use this? What's the point? You can spend at most $12 for drinks on a picnic. So you have a limited budget. You don't have infinite money. Iced tea is $1.50 a gallon. Lemonade costs $2 per gallon. We have to figure out how much of each could I buy. At what point am I buying too much lemonade, too much iced tea? I don't want just one. I want both. I'm needy like that. I need both. So let's write an inequality for that. Okay, I know that iced tea is $1.50 a gallon. So I'm going to do $1.50 for, I'll use X. Why not? So X is going to be lemonade. Nope, sorry, X is going to be iced tea, like the wrapper. Iced tea. What? Okay, so X is iced tea. I have a hard time saying that now. Y is going to be lemonade. If you don't know who iced tea is, that's okay. All right, I've got my equation then. I've got $1.50 for iced tea. I've got $2 per gallon for lemonade. I'm not going to put the .00, but you certainly could. And I know that I have at most $12. I cannot spend more than $12. So I have to say that my money have to be less than 12. I could actually spend exactly 12. So at most means I can spend that $12. All right, I've written an inequality. Write an inequality to describe the situation. Done. Now I need to graph it. So I got to get y all by itself. I'm going to subtract 1.5x from both sides. Good. So 2y is less than or equal to negative 1.5x plus 12. I'm going to isolate the variable and divide everything by 2. I'm going to get that y is less than or equal to negative 1.5 divided by 2. $1.50 divided by 2 is going to be negative 0.75. We're going to deal with that in a second. Plus 6. All right, I can graph. You may have to use your eraser, so if you're doing this in pen, use an eraser. I'm going to graph. So I've got my y-intercept, 6. Boom, done. Now I need to use that slope. Negative 0.75x. That's really hard to graph, 0.75, and do it well. So let's change it to a fraction. Slopes are fractions anyways. We don't really want a decimal there. Let's get a fraction. 0.75, well, that's 3/4. 3/4 is a heck of a lot easier to graph than 0.75. It seems like it'd be the same number, so it should be just as difficult and just as easy. But if we have a fraction, we have a ratio, a rise over a run. So I can do a rise of negative 3 and a run of 4. That's way easier than negative 0.75. And so I'm going to go down 3 over 4, got my point. Down 3 over 4, got my point. Got my line. Y is less than or equal to, which means that I have a solid line there. And since y is less than that line, anything down here is going to be a solution. So I've graphed and I've shaded. Now it says, describe reasonable solutions. Okay, give 2 possible combinations of drinks you could buy. Really, any point in that shaded region is a potential solution. You cannot have negative iced tea. You can't have a negative lemonade. So you can't pick points down here. In theory, in like math world, sure, that is a solution to negative 5. However, in the real world, which is where we really, really live, you can't do that. And so this might be a solution. I could buy 2x and 1y. So I could buy 2 gallons of iced tea. And I could buy 1 gallon of lemonade. Again, the point was 2, 1. And I said X was iced tea, Y was lemonade, so 2, 1, 2 iced tea, 1 lemonade. That's a solution. I'm not really using much of my money. I'm not getting as much as I could. So another solution might be right here. For 3, I could buy 4 gallons of iced tea, and I could buy 3 gallons of lemonade. Both are solutions. I can purchase 2 gallons of iced tea and 1 gallon of lemonade, and I've got enough money. I can also purchase 4 gallons of iced tea and 3 gallons of lemonade and have enough money. I cannot get 5 gallons of lemonade and 5 gallons of iced tea. Don't have enough money for that. So that's how we can use that graph to find some potential solutions. What I'd like you to do on your own is I want you to figure out for Dirk, great name, Dirk is going to bring 2 types of olives to the Honor Society induction. go honor society. He's going to bring olives. He's got $10. He can't spend more than $10. No more than $10. Green olives are $2 a pound. Black olives are $2.50 a pound. He's going to buy lots of olives, pounds and pounds of olives. I need you to write an inequality, a linear inequality, to describe that situation. Graph those solutions. Give 2 combinations of olives that Dirk could buy. And we're going to look at these when you get back to class. So have this ready. This will be a test to see who is actually watching this. Have this ready. We're going to look at those solutions when you get back.